Hello everyone, just a very quick roundup on how to go from one base to another. I'm hoping that if I show you the steps I take, hopefully relatively slowly, that will help you answer the questions on the tutorial. Firstly, I just want to show you something I found quite useful. I'm going to write down a very quick binary number here. Okay, and on baseline it states that computers will often use 8-bit bytes. Okay, what that means, okay, not necessarily why computers use it, but a byte, okay, is this. So hopefully that'll fit on. So those 8 digits there is the byte. Half a byte is called a nibble. Okay, and each single digit here is called a bit. It was something I'd forgotten, so it might be useful to you at some point. Anyway, one more thing that I want to go through. Very simply, when you're at school you will have done this. I'm going to write down a random number, so 1, 2, 3. We know that this is our units, our ones. This is our tens, and these were our hundreds. I'm not going to fit 100 in there, but our hundreds. Okay, and I remember doing this, and my kids are going through this at the moment. So that is 10 to the 0, 10 to the 1, okay, and 10 squared. When we're looking at binary, we look at a number that is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and so on. And the same with hexadecimal. It starts off with 16 to the 0, and then it will be 16 to the 1, and so on. Okay, we're only going to look at hexadecimals with 2 digits here. Okay, we know that anything to the power of 0 is going to be 1, so x to the 0 equals 1. Okay, so this number in all of our bases, whatever is present in that section is always going to be multiplied by 1, because that's the power of 0 is always going to give you 1. Okay. So let's use 1, 2, 3 and see if we can work it out in binary. And we're going to go into binary, and then we're going to use the number we find and then work backwards and see if we get 1, 2, 3 again. So we've got 1, 2, 3, and the way I do it is to half it. There are lots of different ways, but this is just the way I find it easiest. So 1, 2, 3 divided by 2. Okay, I can do, it's 61 with 1 remain. 61 halved is 30 with 1 left over. 30 halved is 15 with none left over. 15 halved is 7 with 1 left over. 7 half is 3, oops-a-daisy, getting ahead of myself, is 3 with 1 left over. 3 half is 1 with 1 left over, and I cannot half 1, so I will always have 1 left over. We go from the bottom up, and our number is 1, 1, 1, 1, 0, 1, 1. And using this information, we're going to see if this number adds up to 1, 2, 3. Okay, I'm just going to write it out a little bit neater. So I'm going to have 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 4, wait, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Oh, fiddle, I've done it again. Okay, so 1, 2, 3, 4, 5. Okay, so we've got 7 digits there. So we've got 1, 1, 0. So I'm just rewriting this number here. 1, 1, 1, 1. So this is telling me I have 1, 2 to the 0. So that's going to be 1. It's telling me I have 1, 2 to the 1, and 2 to the 1 is 2. I've got no 2 squareds, so that could be plus 0. I have got 1, 2 cubed, which gives me 8, so 1 times 2 cubed is 8. I've got 1, 2 to the 4, which is 16. I have 1, 2 to the 5, which is 32. I have 1, 2 to the 6, which is 64. Okay, when you add all of those numbers up together, so 64 plus 32 plus 16, many apologies, plus 8 plus 0 plus 2 plus 1 gives you 1, 2, 3. And so now we're going to go from our decimal to our hexadecimal. So as I said before, okay, we've got 16 to the 0 and 16 to the 1. And we have to work out how many 16s we have and then how many 1s are left over. Okay, so the first thing I would do is put our number in. So we've got 1, 2, 3. I'm going to divide that by 16 to see how many go into the 16 column. So I've got 1, 2, 3 divided by 16, and I'm only looking for whole numbers now. So whole 16s that go into 1, 2, 3. So in fact I'm going to write down what I'm doing. So 1, 2, 3 divided by 16, okay, gives me 7.6875. The number I'm looking for though, I only want the whole numbers. Okay, so whole number. So we know that the number that goes into this column, okay, of the hexadecimal is going to be 7. Okay, and the hexadecimal that matches 7, okay, is 7. So we can put here the number 7. Okay, then we need to find out what our remainder is. So you can either take 7 away from this number because we've already used it and then use our 0.6875 times 1, 2, 3 to get our remainder. Or you can multiply 7 by 16 because that's how much this is representing here. Okay, and the 7 times 16 gives us 112. So we then have to take that away from 1, 2, 3. Just put that there so my working out is clear. And that gives us 11. Okay, now 11 in the hexadecimal here is B. So that means our number or our digit that goes into the 16 to the power of 0 column is going to be B. Okay, now we can work backwards. So what I can do now is to come up with a different hexadecimal number. So if we go from, let's look, so if we go 2F, for example, if I have a number 2F, I know that this is the 16 to the power of 1 column, and this is going to be the 16 to the power of 0 column. I know that this is going to be whatever decimal value F is, multiplied by 16 to the power of 0, which is 1. So F here is 15. So our number in the units is going to be 15, and we can almost put that to one side for a moment. We then have to look at how many 16s to the 1 we have, which is 16. So 16 to the 1, hexadecimal 2. Okay, well our hexadecimal, found my pen, hexadecimal 2 is actually 2 in decimal. So that's going to be multiplied by 2, gives us 32. 32 plus our 15 that we put to the side. Okay, that's going to give us 47. Okay, and as a sanity check, because it's really important to assume that you haven't got it right and to work backwards, we can start with 47 like we did with 1, 2, 3. So we'll go 47. Okay, and I'm going to divide that by 16. See what it gives me. So I've got 47 divided by 16 gives me 2.9375. Okay, this is my whole number. Okay, so that is going to be what's in my 16 to the 1 column, so that's going to be 2. I can then either multiply by 0.9375 because I've already used the 2, or I can multiply 16 by 2 again, so 2 times 16 gives you 32, so 2 times 16, so we're just doing this column here, gives me 32. I can then take that from 47, okay, because we have that given to us, which gives me 15. Okay, I know that there's going to be the hexadecimal unit here for corresponds to 15, and that's F. So that's my hexadecimal number. Okay, if you want to go direct, so I'm just going to change my pen colour again. If you want to go straight from hexadecimal to binary, so we can use this number again. So if our hexadecimal number is 2F and we want to go to binary, okay, all we have to do is to use our table and find the corresponding number. Okay, and that is going to be 0, 0, 1, 0, 1, 1, 1, 1. And we can again sanity check that. So this would be 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and 2 to the 7. Okay, I'm just going to write above what actually that corresponds. So 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, 2 to the 4 is 16, 2 to the 5 is 32. And each time I'm just doubling like we were halving as we went down here. 2 to the 6 is 64, and 2 to the 7 is 128. And then we're going to add them up. So we've got 1, 2 to the 0, which is 1, 1, 2 to the 1, which is 2, 1, 2 to the 3, 2 to the 2, which is 4, 1, 2 cubed, which is 8, no, 2 to the 4, 1, 2 to the 5, which is 32. I'm not going to add these on because they're not there. Okay, so then we add all of these numbers up. So 2 plus 8 is 10, plus 32 will give us 42, 4, 46, and 147. Gosh, my brain went blank then, so 47. Okay, and there's our hexadecimal to decimal, hexadecimal to binary, and to sanity check we've gone binary to decimal, and we've already done it this way round and this way round. So it's really lots of different sanity checks to make sure you've got the hexadecimal, the binary and the decimal all correct. I hope that's helpful. If you have any other questions, please email. Thank you very much. See you again.